Hi everyone, this is Lady Emmanuel on this wonderful morning. I am creating a video for domain range boundary. Before we get started with the collaborative domain range activity, I want to review information from perhaps middle school for math. So my question to you is, what is this called? What is that called? What's the difference? And I know some of you already said, oh, this is just a line segment. It's a vertical line segment. And what does a line segment mean? Line segment, it starts and it ends. Okay, it starts at a point, it ends at a point. It does not continue on, therefore it has boundary. It stopped here. Okay, if it's vertical, what does vertical tell you? It runs north, south, up and down. This is north, that's south. You can say this is up, this is down. What does up and down mean? Increases. This means it's increasing, and I will put a plus there. And down here, it means it's decreasing. I'll put a negative there. Okay. What does a line mean? A line is a collection of points that continues on and on forever. Okay, in both directions. This is a vertical line. Vertical line has no boundary, whereas line segment has boundary. The arrows tells me there is no boundary. It continues on. What does it mean to continues on? This, if it's going up north, and this is down south, north is increase, it's up. That means it's approaching positive infinity. If it's going down and it's going south, south is approaching negative infinity. So this is increasing, decreasing. The arrows only go in one direction. It's just going north because it's a vertical line. Whereas here, what kind of line is that? It's running left and right. Left and right. And again, it's a line. It doesn't stop. It continues on and on. Left means it's going to the west. Right is going to the east. When you go to the east, go to the right, that's an increase. When you go to the left, it's a decrease. It's approaching positive infinity to the right, negative infinity to the left. Okay. When it's horizontal, the arrows is going to one here it's going one direction, it's going just west. Here it's just going east. What does the line segment tell you? It stops. This has a boundary. Here it continues on. Here it stops. It stops here and it stops there. Okay. Although yes, it's this is approaching negative, but this is a stopping point. So it's a certain location. Okay, you made it to a destination. Here you don't make it to a destination. You just keep going on and on and on. Okay, like a long, boring story. Okay, that's that. Now what happened if the line is slanted? Here we got a positive slope. It's slanted. Now knowing that I know if you go up, this is north. I know this is north, so it's going up, so I know it's north. But it's also going a little to the right. Just its direction. This is going northeast. Okay, northeast. So I would look at this and make my connection. I say, okay, if something is going north, then that means it's positive infinity. If it's going east, it's also positive infinity. Okay, so this is going in two directions, northeast, just like driving, guys, or riding somewhere, northeast. What country is northeast of Texas? Not country, let's say state. What state is northeast of Texas? Okay. How about what state is south? Ooh, is this east? It's going to the west. And it's going down, so it's southwest. What state is southwest? Okay. So it's two direction. What does south indicate? It's a decrease. Okay. It's a decrease. And since that's an arrow, then that means it has no boundary. It keeps going on and on. So it's going to approach negative infinity. The west is also approaching negative infinity. Okay? I just sort of want you guys to understand this. Here, this here is going northwest. west. Here, south, that arrow, it doesn't stop. It's approaching southeast. It's just traveling southeast. North is positive. West is negative. South is negative. East is positive. Okay. So just remember it. Just remember, you make you think about the quadrants. If you really think about quadrant 1, quadrant 2, 3, 4, think about your order pairs. It's the same concept. Okay. Now looking at the different shapes that are not line. What happened here? If you had, like here, I didn't put no points or arrows there. If I put arrows, then you know what happened. It continued on, on. My question to you, what does this mean right here, this vertex? Does that mean it continue or does it stop? You're right. That's a boundary. It's a boundary. Okay? It doesn't go below. Nothing go below. It go up. It's going to go up. So whatever this boundary is, it's going to be greater than that. If this was 5, it's going to be y is greater than 5. Okay? This is going to be greater than. Okay. And I'm not writing down. You can write it. Also here, look, this graph is here, and then it goes up. Here, it goes up. The boundary is here. However, from the boundary, it's an increase. Here is a boundary. From this boundary, the graph is not going up. The graph is going down. So it's decreasing from the boundary. Decreasing from the boundary. Here's another. All the way across. So what about that? You just keep straight across. Here's the boundary. What is happening? There you go. It is increasing from the boundary. Okay. Here we have it. I turned it left and right. So if you look at this, the boundary, this graph right here, it has a boundary. So this graph, it stops. It's not going towards the east. Okay. So from this boundary, it's going towards the left. So that means that left, go back up. Left is going towards the negative. Is it going to be infinity? No, because it's a stopping point. Stopping points mean it doesn't continue on to negative infinity. Same with this. It's a boundary. This boundary and this boundary is going to the, there you go. It's going to the east. It's positive. So whatever it is, it's going to be greater than. X is going to be greater than, whereas here, X is less than. Less than equals 2, greater than equals 2. Okay. If it's a solid line, it's going to be greater than or less, greater than equals 2 or less than equals 2. If it's an arrow, you see that? It's going to go on forever. Here, it's going to stop with that. It's going to have an inequality where you got a smaller number and a large number. This is just have one part. Okay. I want to go over that first with you guys. So now, let's go over some of the problems that you would encounter. And you know what I like to do? I do like to highlight my domain pink. So highlight all your domain pink. That's for our X. We know that's our X. Okay. Then I'm going to highlight my range width. There you go, which is Y. Okay. So I'm going to go through, highlight range. So when I put my boundaries, lines, I would know if there's, I would have it color coded so that makes it easier for us. So let's go through here. Sorry about this. Let's look here at number 1. Oh, this sort of made me think about an array. It started at one point and it continues on. Okay. Now, if you look at this, we do have an arrow here. We have an arrow. Now, that arrow is going north because it's going up. It's not going down. So we'll say this is going north. North, is it east or west? Northeast. Okay. So if it's going northeast, that means it's positive. Okay. And it's positive for the east. And you probably, so how does northeast relate to your domain and range? Okay. I'm glad you asked. Turn back over. When you're thinking north and south, this right here is for your Y. That's your Y value. West and east, that'll be for your X. Because X goes